Good morning. Today we are going to be working through Lesson 7-2. I apologize right now for the video being a little bit longer today, but it takes a little while to get through everything. So for the math message, I want to just remind you that we can write fractions that are greater than 1 in several different ways. For example, if you see the large red circle there, that is worth 1. So it asks what is 3 large circles, and then the pie that's blue with the one piece missing from it worth. Well, if you look, there would normally be 6 pieces that would fill that blue pie. So therefore there's 5 pieces, so that would be 5/6, and then there's 3 whole. So it would be the same thing as 3 and 5/6. So then it says below, a mixed number name is 3 and 5/6. 3 and 5/6 also means 3 plus 5/6. A fraction name is 23/6. Think about it being done in all sixths, and we've covered this at the beginning of the year with our fraction circles. So you could have taken all of the sixth pieces to complete all of the whole pieces that were up in red. So you can see there's 6/1 in each complete pie, and then there's 5 in that last one. So if you add all of those blue triangles up, you'd come up with 23, and then there's 6, so you could be writing it as 23/6. So for the rest of your math message, you need to go ahead and complete the first math journal page in your module. It's page 237, and go ahead and do both sections of that, and then I'll be going over them. So at the beginning of the page, it says to write the following mixed numbers as fractions. You may use fraction circles with the fraction number lines poster to help you. Obviously, we didn't take our fraction circles home with us, but we can always draw pictures. So it starts off with 1 2/3, so we're just rewriting that as an improper fraction. So if we think about that, if we have, if we have a full circle for our one whole, and then for our second circle, we're going to divide it into thirds because it's 1 2/3. So here I've shaded 2/3 of it. Then we're going to break this big one that we've already said is one whole into thirds as well, and just say we've used all of the thirds. So how many thirds do I have altogether? Well, I have 1, 2, 3 here, 4, 5. So that means my numerator is 5, and then I was counting by thirds, so I could rewrite that mixed number as 5/3. Another way I could do it is I can just multiply my whole number 2 by the denominator 5. 2 times 5 is 10. Then I have to add the 3 that's in the numerator right here. So 10 plus 3 is 13, which makes my numerator 13, and my denominator is still a 5, because that's what was started off with in the problem. So my answer here is 13/5. You may use whichever strategy is easiest for you, just so long as you come up with the correct answer. Number 3 and 4, I'll do it the same way. So 5 3/4, we can say that using fraction circles, we have 5 wholes. And then my last one, I need to divide into fourths because that's my denominator. So I have 3 of the 4 shaded in. Then I would also have to break each one of my wholes into fourths as well to see how many total I have. So if I counted all of those, I would have 4, 8, 12, 16, 20, plus the 3 here, so I would have 23/4 in total. So my answer here is 23/4. Now for 6 1/5, I'm going to try it another way. I'm going to just multiply whatever my whole number is by my denominator. So 6 times 5 equals 30. Then I have to add that 1 that's in my numerator, so 30 plus 1 is 31, and then my denominator is still fifths, so my answer will be 31 fifths. Write the following mixed numbers as fractions. You may use fraction circles or the fraction number lines to help you. We're still doing the same thing with these. So for this first one, I'm going to draw my 4 holes. These are like I've got 4 whole fraction circles. Then my fraction is 7/8, so I'm going to have to divide this one up into eighths. So I'm going to divide it like this, and then 7 of them will be shaded. All but one. So since we're using 8 as our denominator, we would have to divide all of these other ones into eighths as well to count all of our total eighths. So then if we counted all of those, we'd have 8, 16, 24, 32, plus the 7 here in this last one. So 32 plus 7 is 39. So total we have 39 eighths. And then 3 6/4, we're going to multiply that whole number 3 by the denominator 4. 3 times 4 equals 12. Then we've got to add what's in the numerator, so 12 plus 6 is going to give us 18, so that's our new numerator. So our numerator is 18, and the denominator stays the same, which is 4. Now, for the bottom set of problems, we're doing just the opposite here. So they've given us the improper fraction, and we're going to write it as a mixed number. So our first one is 7/3, so I can draw my fraction circles again. So I'm going to make it thirds. Whoops, I didn't do that real well. There's 1, 2, 3, 4, 5, 6. 6/3 right there. So we have 7/3 altogether. So there's 7/3. So how many holes do I have filled in? I have 2 holes plus 1/3 here. So my mixed number is going to be 2 and 1/3. If I wanted to use the other method with just my fractions, remember that line also means divided by. So for number 8, I have 2 over 1. So I can say that's the same thing as saying 2 divided by 1. What is 2 divided by 1? Well, the answer is 2. So my whole number here is 2. That one was a little bit easier to do. This time I'm going to flip-flop them around and do the first one with our numbers. So 18 divided by 4. We're going to just do the math with this one. How many times will 4 go into 18? It will go in there 4 times. 4 times 4 is 16. 18 minus 16 is 2. 4 won't go into 2, so that becomes our remainder becomes our fraction. So remember, we make that remainder our numerator, and the divisor over here is our denominator. So our answer is 4 2/4. Over here we have 9/3. So once again, we're going to do fraction circles, and we're going to divide them up into thirds. So 1, 2, 3/3 there. 4, 5, 6, 7, 8, 9. That takes up all of my thirds. How many whole circles do I have filled in? I have 3 whole circles. So my answer there is just the whole number 3. Okay, for number 11, 22 over 5. So if I do my circles again, I'm going to draw them divided up into fifths. So 1, 2, 3, 4, 5. I'm not an artist, as you can tell. 1, 2, 3, 4, 5. Here's another one. 2, 3, 4, 5. Okay, how many do we have so far in fifths? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Gotta do another one. 16, 17, 18, 19, 20. And our numerator over here is 22 fifths, so then we'd have 2 more. So how many holes do we have here? We have 4 whole circles with 2 left over. So our mixed number would be 4 and 2 fifths. Then for number 12, 16 over 8, we're going to just do 16 divided by 8. We know that 8 goes into 16 2 times, so our answer is 2. So today we're going to continue working on multiplying mixed numbers as fractions. Now, if we start off with the problem, 3/4 times 1/6 equals, will the product for this problem be greater than or less than 3/4? The answer is the product will be less than 3/4 because 3/4 is being multiplied by a number that is less than 1, because 1/6 is less than 1. If I multiply these two numbers, is the answer going to be greater than or less than 1/6? Once again, the product will also be less than 1/6 because we are taking only a fractional part of 1/6. Both of the numbers we're multiplying are less than 1. Now, think about the algorithm that you know for multiplying two fractions. To multiply two fractions, you multiply the numerators of the factors to find the numerator of the product, and you multiply the denominators of the factors to find the denominator of the product. So, if we multiplied straight across here, our numerators, 3 times 1 gives us 3, and then multiply straight across for our denominators. Remember, when multiplying, you do not have to have the same denominators. 4 times 6 is 24. So our answer is 3/24. Now, we can also check our work by using an area model. That's what is drawn over here in this picture, and you can see they've labeled the x-axis down here. They've divided those into fourths, so they have shaded 3/4 units. Then on the y-axis on this side, they've broken those down into sixths, so they've shaded 1/6 of those. So then you can see, if you count out the total number of squares here, there are 24, and there are these 3 that are actually shaded, so that matches our answer of 3/24. So now let's pretend that we have the problem 2 times 1 2/3. So if we want to use the same strategy that we used in the last problem, we can start out by changing each of these numbers to improper fractions. So when we write 2 as an improper fraction, we always put the whole number over the number 1. So 2 rewritten as a fraction is 2 over 1. Then we're going to multiply it by 1 2/3. We can use one of those strategies that we just used. We're going to multiply 1 times 3, which is 3, and then add the 2 in the numerator, which is 5. We're going to put that over our denominator of 3. So this mixed number is equivalent to 5/3. Once again, we can follow our multiplying rule of multiplying our numerators. 2 times 5 is 10. And then multiply our denominators. 1 times 3 is 3. So we get an answer of 10/3. Now we can also use our area model to check ourselves, just like we did in the last problem. So if you notice, the horizontal line down here at the bottom is shaded for the rectangle being 2 units long. So here's 1 and here's 2. They've shaded it all the way over. Then along the x-axis over here, they've broken those parts down into thirds because our denominator was a 3. So they have shaded in there. They've gone up to 1, and then here's 1 2/3. So they've shaded all of those in as well. So then if you count the total number of rectangles in this picture, we have 10 shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 shaded, and they were in thirds as well. So once again, we can check, and the answer is equal to 10 thirds. So we could leave the answer as 10 thirds, or we could even change that to a mixed number and say that that is the same as 3 1/3. When multiplying mixed numbers, you're going to need to decide whether to report each product as a fraction, like we started out with, or as a mixed number. So when might it make sense to report a product as a mixed number? When we solve real-world problems, when you want to compare the product to the factors that you started with to check your answer. When might you want to use it as just a fraction? When the product will be used for further computation. So if I need to use this answer to do some more math, I might want to leave it as 10 thirds. Okay, we're going to try a few more practice problems before you do your work for today. Alright, so the next problem that we have is 6 2/3 times 2 1/4. So we're going to change each of those to improper fractions. I'm going to continue using the just multiplying the numbers, but you could still use your fraction circles if you need to. So 6 2/3, we're going to multiply the 6 by the 3, which gives us 18, and then add the 2 on top, which would be 20. So this is going to be 20 over, we keep our denominator of 3. Then for our next number, we're going to multiply our 2 times 4, which is 8, plus the 1 in the numerator would give us 9, and keep that same denominator of 4. Then we can multiply straight across with both our numerator and denominator. So 20 times 9 is 180, and 3 times 4 is 12. And if you want to reduce that down, 180 divided by 12 equals 15. So either answer is acceptable. You could either do 180 over 12 or 15. Okay, the next one we're going to look at is 7/8 times 5 1/2. 7/8 is already written as a fraction for us, so we're good there. And then we're going to convert our 5 1/2 to an improper fraction. So 5 times 2 is 10, plus 1 in the numerator is going to be 11 over 2. Multiply straight across again. 7 times 11 is 77, and 8 times 2 is 16. Then if we want to convert that, we can divide. 77 divided by 16 gives us 4 and 13/16. So either way is acceptable. Okay, and then the last one, 3 5/6 times 1 3/4. We're going to multiply our 3 times 6, which gives us 18, plus 5 is 23. Keep the denominator 6. And then we're going to multiply that by 1 3/4. So 1 times 4 is 4, plus the 3 is going to be 7 over 4. Once again, multiply straight across. 23 times 7 is 161, and 6 times 4 is 24. Then if you want to reduce that to a mixed number, 161 divided by 24 equals 6 and 17/24. Okay, now I want you to go ahead and complete the other math journal page that's in the module. It's page 238. I will just show you the answer page for that. I'm not going to go through all of it because it'll make this video really long. So I'll show you the answer page for it. Once you finish that, Then you need to do your home links 7-2 and math boxes 7-2. And there is a place to turn both of those in, so make sure you turn those in the proper places when you get done. And then if you have any questions or anything, just send me a message on Canvas. Thanks, and I will see you next Tuesday. Here are the answers to page 238 in your math journal. So make sure you look through those and make sure you understand how they got those, and then go ahead and do your home links in your math boxes.